So to get my translation vector, so when I add or subtract here negative 7 minus 3, that is the negative 10, negative 1 minus 5, that is the negative 6, and that one there becomes my translation vector. So So my example for an object A, 3, 5 is mapped onto A prime, which is 5, 1 by translation vector T1. Find the coordinates of B prime. Find the coordinates of the image B prime of B, which is negative 1, 10. Now here we are having 2 points and 2 images, but we do not have the translation vector. So that means that I'm going to first use the first object A and its image A prime to get the translation vector T1. Then from there, I use it to get the image B prime of B. Object plus the translation vector gives me the image. So my object A plus my T1 is giving me A prime. The A is 3, 5 plus my T1 is equal to the B, which is 5, 1. I take A the other side. So this is going to be 5, 1 minus, this is 3, 5. So when I subtract that one there, I get a 2. That one there, I get a negative 4. Then from there, now I'm going to use this translation vector because they are saying also it is the same vector that translates B onto B prime. So my B plus T1 is equal to the B prime. B is negative 1, 10 plus this one here is the 2, negative 4, the translation vector should give me the B prime. So when I add, that is going to be positive 1. When I add, that's going to be positive 6 to get my B prime. This one here is a vector, but the question asked for coordinates. So now I write them as coordinates. Coordinates of B prime are 1, and 6. So as simple as that. So now we can look at the addition and subtraction of vectors. Suppose I'm having my vectors A and B right there, the x1, y1, b, x2, y2. So we either add or subtract vectors, that is the corresponding values, that is the corresponding x values, and then the corresponding y values. So this here means the addition x, if it is A plus the vector B, that is x1 plus x2, then y1 plus y2. Then if it is a minus, that is x1 minus x2, then y1 minus y2. As simple as that. Only that here I've just combined the signs to mean that it is either addition or either subtraction, which is the same as this here. So the x, suppose I have my coordinate there, we say this one is coordinate form, and then this one here is going to be the vector form of, if this is my point A, then my vector A is going to be like that in vector form. Let us look at the examples. So my example 1, given vectors P, which is 7, 1, Q, 5, negative 6, and R as 3, 4, find Roman 1, P plus Q, then Roman 2, Q minus R, then Roman 3, P minus, into the brackets, Q plus R. So my solution here, Roman 1, P minus, my solution 1, P plus Q. What I'm going to do first is to substitute the vectors P and Q. So this is 7, 1, then plus 5, negative 6. You have said the addition, you add the x values and then the y values. So this is going to be 7 plus 5, then 1 plus negative 6. So when I add here, I'm having a 12. When I add here, I'm having a negative 5. So that is my P plus the Q. Then I can go to my Roman 2. Q minus R, I substitute. Q is 5, negative 6, minus, this is 3, 4. So I subtract, we subtract x values, we subtract the y values. So this is 5 minus 3, that's going to be a 2. Then negative 6 minus a 4, that's going to be negative 10. So this is my Q minus the R. My Roman 3, P minus, into brackets, vector Q plus vector R. So the first thing always to substitute those vectors. Vector P is 7, 1, minus the Q, which is 5, negative 6, then plus vector R, which is 3, 4. Then now I'm going to first deal with the vectors inside the bracket. So those inside the bracket, when I add them, 5 plus 3, that's going to be 8, negative 6 plus 4, that's going to be negative 2. So that is what was inside the bracket. And now finally I have 7 minus 8. These brackets here shouldn't confuse you. This is like 7, 1, minus 8, negative 2. These brackets shouldn't confuse you. When we subtract, finally, I'll be having 7 minus 8, the negative 1. Then 1 minus 2. 1 minus 2. This becomes a plus, and I have a 3. So I'm having that number 2 given vectors A 11 5, B negative 1 2, and C as C and C plus A is equal to B. Find vector C. So this is the lead we have in the question. These are just vectors. Then the other one is a lead. We must use that lead to arrive to vector C. So I'm going to first write the lead C plus vector A is equal to vector B. C is the one I'm looking for. I substitute these ones that were given in the question 11.5 is equal to negative 1, 2. I take this vector, the other side, this is going to be C is equal to negative 1, 2, then minus 11, 5. So this one here, when I subtract negative 1 minus 11, that's going to be negative 12. Then 2 minus 5, that's going to be negative 3. So that is my vector C. Wandise mwampadde eddakiika 3 simanyi waziweddeyo. Ezinagwayo nyongera eddakiika. So we can now look at scalar multiplication by a vector. A scalar in physics is that physical quantity which is having only size or magnitude. When it is multiplying a vector, the Ka is the same as K times vector A. So I substitute the vector A from here, I bring it there, then I multiply now the scalar by everything which is inside the vector. So that is the k times the x, and that is the k times the y. So in our examples, the one we have been having, let me say vector b, which is equal to -1, 4, -1, 3. So if I have a scalar, let me say I'm having a scalar a half times my vector b. So this one here is going to be a half times -1, 3. Then the half is going to multiply whatever is inside the bracket, that is a half times the -1, and then a half times a 3. So that is what we are going to be talking about under the scalar multiplication by a vector. So my example 1, if vectors A is equal to 2, 3, and B is equal to -4, 10, find for A, Roman 2 there, then Roman 3 there. So my solution, Roman 1, that is 4A. First thing is to substitute 4 times vector A. Vector A is 2, 3. 4 is going to multiply the 2. 4 is going to multiply the 3. 4 times 2, that one is 8. 4 times 3, that is 12. That is 12. So this is 4A. Then I can go to my Roman 2. 3A minus a half vector B. Then I'm going to first substitute 3 times my vector A, which is 2, 3. Then minus a half vector B is -4, and then that one there is 10. So this is going to be 3 times 2, 3 times 2, then 3 times 3, 3 times 3. Minus a half is going to multiply the -4, then a half multiplies the 10. So this one here is going to be equal to 6. Then this one here is going to be equal to 9 minus, when I multiply that there, this one here is going to be negative 2. When I multiply that one there, it's going to be a 5. Now, this takes me back to the addition and subtraction of vectors. So 6 minus negative 2. 6 minus negative 2. That one there, I get positive 8. 6 minus negative 2. That one there, I get positive. That one there, I get 8. Then 6 minus 9 minus 5. That one there, I'm going to get a 4. And that one is my 3a minus a half b. Now, my Roman 3, we said we are going to substitute first 5. Vector A is 2, 3, 2, 3. Then plus 2, my vector B is negative 4, 10. So when I multiply here, that's going to be 10. When I multiply there, that's going to be 15. Plus, when I multiply here, that's going to be negative 8. When I multiply there, that's going to be a 20. So finally, when I add 10 plus negative 8, that's going to be positive 2. Then 15 plus 20, that's going to be 30, 35. So that was all about example 1. So we shall meet in another lesson.